Recording it. Okay, welcome everybody. I'm really excited to be kicking start our first data science workshop series. The first series topic is going to be high-level data science insights, and it is going to be presented by Michael here. And before we get into today's presentation, I actually want to do a little bit of introduction for IntelNova. As you probably already heard, IntelNova Solutions is hosting this workshop, and we also have a co-host, which is SEGA, which stands for Student Exploration Geophysics Association at University of Calgary. So a big thanks for SEGA for co-hosting this workshop. And basically a little bit about IntelNova is we're an organization that helps bridge the gap between data science enthusiasts and students and the industry. So if you're interested in learning more about data science or interested in actually switching your career path to a more data science or IT related career field, but you don't really know where to start, you're at the right place. IntelNova can provide you with that support. We host workshops and we have a lot of mentors that supports you through your learning journey. And our mentors are from different fields such as the energy industry. And Michael today is from, he's currently working for CMHC, which is the Mortgage Insurance Group of Canada. And we also have people from really all over the industry, different industries such as neuroscience, the health sector, and e-commerce. So it's a very diverse experienced crowd, and I'm sure we can provide you with a lot of different learning opportunities. And on top of all of the workshops, we also bring you the projects that you can get hands-on in practicing the skills that you just learned within all of these workshops. So we're actually planning to launch our first project, which is building a web application using Plotly Dash and one of the open data sets that we find for you guys next week. So you guys can start working on that project, and we will have an interesting work session together in 4 weeks of time, I believe, to introduce you our solutions, and we can work together and really build a scalable product, and eventually to see if there's any like marketing potential. So really you can have a wide range of experience no matter what your interest lies. So before we get started, I also want to thank our sponsors. Joanne Yan here. She is auto insurance, home insurance, commercial insurance, and travel insurance broker. And we also have another sponsor, which is CCCTA. So thanks for our sponsors. And so before we get started today, I actually have a poll for you guys. So if you can kindly help me answer these questions, it will really help us gauge how to design our next workshops. I will put this up for 1 or 2 minutes just to wait for a response. Actually, probably 30 seconds is enough. There aren't a lot of questions. Okay, perfect. All right, thank you for your response. And let me introduce Michael to you. Michael, 1 second. Let me share my screen again.
I can actually just take it up from
Okay,
here.
yeah, you can take it from here. You can introduce yourself. Yeah, go ahead, Michael.
So I won't give you too much of a coffee walk to start introducing me. All right. So which of the screen can you guys see right now? Can you guys see any of my screen?
I can see your presentation.
Okay, you can see my presentation. Okay, so I need to do some of those sanity checks sometimes. It's been so many years virtual and you still can't be sure what you're showing when you have multiple screen before you. All right, good evening, everyone. I go by Michael, though you may be saying my actual first name and last name. My middle name is Michael, so I don't want to get my presentation too busy. Putting Michael there. That's just kidding. Um, I guess one of the things I'm really excited to say this evening is that IntelNova is picking up a passion that I really want to grow, which is growing a community of people that are looking to transition their career and having them get the right support they need to confidently make every step forward, not just to make step that are probably not directionally correct to progress that you really want to achieve for your career in the digital space. So I'm very excited. I am very cool with this idea, and if you see the caption for today's presentation is really around knowing where to begin your data science career. I wouldn't call it even data science in the first place. I would like really love to have used a word like data discipline career, because it is a huge space right now. A lot of structure to how you comprehend this space will save you time, will give you more confidence, and probably would make you, move closer to what your goal or intention is. Because I hear many times people feel like, oh my God, data is too big. I don't know where to start from. I don't have programming knowledge. I don't have this, and it's really kind of concerning, especially for people that have little to no experience when it comes to running a code, or people that get very allergic to the dark screen. So I can really assure you that the data discipline is as extensive as you can think about it, and is as also specialized as you may also think about it. So this evening I'll take you guys through a couple of conversations around this. I must tell you guys that I have a little bit of bad habits, which could be good depending on the way you see it. I I don't really have all my thoughts, infused into a slide. So you could get me talking really, really extensive about something. I just wanted to pay attention, and I'm very sure that the conversational part of our interaction this evening would go a long way. So we have a Slack channel. We want to do it the right way. We want to really make a community out of these engagements. So the Slack channel is going to be on the chat. I think it's on the chat right now. You guys can click on that link and be part of the community so that you can be aware of what may be coming up. So it's starting this way, but I can tell you the progress is going to be huge. We're trying to get as much, professional network to come in and chime in and really bring value to people that are looking to progress career in the data science field or data discipline as a whole. So feel free to join our Slack channel and also visit the website. And just to let you also know that all of us here that are starting this off, we are just individual professionals working in one field or the other, but have that centerpiece interest to help individuals get into the career, to make that career data career transition they would like to. All right, so without further ado, let's get into it. So, well, I'm going to keep my introduction very succinct, and you should assume that you're not seeing the last bullet because it can be a little bit, uh, suggesting something that I don't really want to suggest, because you may think that, oh, it takes to have that maybe a PhD or something to really get into the space of being confident that you can be a data scientist. But I really want to tell you guys, I started learning Python in 2017. and I was frustrated. I dropped it in 2017. I was starting off my PhD. I I wasn't even sure what it means to write any language. I could remember getting a course on Udemy, and most of you must have done that. And I started trying to, understand how to use Python to implement just some very basic, programming instruction. But it wasn't much of fun. Then I didn't last so much on that. Though I kept on persevering and pushing on. I took courses intentionally that will make me learn Python. And in 2019, I got the opportunity to join ExxonMobil as a data science researcher and ML developer. And that really, started helping me to see how structure can make difference when you want to learn something. If I've gotten somebody that could have told me how I should learn Python, I think it would have saved me a lot of time. So under that inspiration, I always feel like I hold something out there to people and individuals that are looking to probably get more confident with something that may look totally alien to them. Then I left Exxon for CMHC, which is the Canadian Mortgage and Housing Commission, an excellent place to work. And I'm seeing data in a different fashion now. So that has really also kind of pushed my depth of experience to another level. And we'll all be benefiting from that experience from the conversation we're going to have this evening. Then I have very genuine passion for sharing knowledge, even if I don't know so much. I have a very genuine passion for sharing knowledge and learning from others too. So it's a lifelong passion for me. And just to get you guys to know, I'm also working on a PhD around machine learning application to subsurface asset optimization. I got some very interesting milestone in past week that makes me feel excited about the work I'm doing on the PhD side, but there's still a lot of ground to cover. So that's me really speaking about the experience I've gathered around this space, and I think it's probably going to be very beneficial if we, get to look at what would be the path to approach your intention to be a data practitioner, so to say. Let's use that buzzword here. Okay, so and if you have any question, please feel free. You can probably put your question in the chat. I have colleagues here that are willing and able to help coordinate that question answering section, and we can really interact and get your question answered in large means. All right, I wanted to start by sharing, what I call my thoughts about data science. Really, let's just pretend it's still data science by large means I'm talking about, because I'm going to try to explain and enforce some boundaries between data science and some of the other similar disciplines that are in the data domain. So first of all, is that I'd like to let you guys know that data science is a transparent field. And what I really mean for by that statement is that you can really get to practice as a data science in any industry that you find yourself. So it's not a skill that is really restricted to a niche. Like you could see from my experience, my background majorly is in petroleum engineering. I happen to work in Exxon, not primarily to do petroleum engineering, but to kind of bring a little bit of that source of it experience and blow it up with the machine learning capability and see how we can deliver some intelligence to empower some business needs, right? So data science is really transparent. So be rest assured that if you put your time to learn this career path, you can easily change industry. We can see through it in in the core traditional IT industry. You can see through it in subsurface discipline. You can see through it in manufacturing. You can see through it in transport and whatnot. And it's just a kind of career that really helps you to scale the options that you may have. So there will be no concern for you to think that maybe your skill set probably would be only relevant to say to subsurface or to wherever. And keep an open mind too. You might start your career maybe with say company like Skip the Dishes, where they're really solving time series challenges and, optimization challenges. Or you could start your career, with somewhere like if you will. So the next thing is that background in analytical discipline can help, but it's not a prerequisite. One of the, very inspiring data scientists that I follow very much is Jeremy Howard. Jeremy Howard actually studied philosophy. His first background is philosophy. But, if you think about his contribution to the AI machine learning space, he wrote the first AI package and is, doing some really cool stuff now with Swift. And one of his papers recently actually make it to the state of art benchmark, and that's kind of inspiring for you to see someone that has a philosophy background. So if you are here this evening and you're trying to score yourself based on how correlated your background is to statistics, to math, you may probably not be doing it right. I think your background may be an advantage, but it's not really a prerequisite for you to emerge as a good data scientist. Now, the other thing I really want to impress on your, on your conscious sense of or perception of this career is that you can start this career as a science, but you will only progress, with hearts. What that means is that, it's kind of okay for you to learn things around, learn about Python, learn about all those algorithms, those are science, about optimization, but it gets to a point where the only thing that will make progress, that will record progress for your scientific knowledge will be hard. You just know that, okay, if I'm designing my deep learning architecture, I think what just works out of the box is like 4-layer, 20 neurons and these, and you just need those numbers as heuristics, and it works very well for you. Like I was talking to a friend of mine doing his PhD in the UK, and we're trying to do some out of time samplings, and we wanted to try like one architecture right off the bat. The guy said, I have something that works. I said, what's it? Just use 4 layers, just use this, use this activation function, use this, and it works. I said, wow, this works. It may take you a lot of time for you to figure it out only by science. But with hearts, sometimes, of course, it can really double the space of your science. So keep an open mind. A better data scientist will be the one that have really seen a lot of data, that have tried different, problem structures, and have also tried to implement different model designs or solution designs, if you will. So the next point is that it is more about using tool than perfecting the tool's knowledge. I've seen some people that want to become a data scientist, and they want to get, AZ204, they want to get all the Azure certifications. And you got to understand that this science is not really about you being an expert in a tool. It's about you really using that to solve a problem. I'll give you guys an example. I went from I was going through a startup interview at a point, and they gave me a very simple question, and I solved it in a Pythonic way. And the guy that was reviewing the code session was like, you didn't use this, you didn't use that, you didn't use, it was talking about some software concept, heap, blah, blah, blah. So honestly, I don't know about what you're saying. Well, you want me to do this stuff, I have done it. And the guy is trying to score me on how much I know about a specific tool. But really, data science, in actual fact, is really not about you perfecting your knowledge about a tool, but with experience, you can get to cover a lot of knowledge. So don't see, for instance, like, AWS as a certification that you must get, Azure like a certification that you must get or something. You just need to know what use case you're trying to empower, by engaging that tool, really. So the other thing is the concept is usually simple, but the implementation may be complex. If you think about deep learning is just it's a very simple concept, right? Well, you start hearing implementation of tensors, back propagations, and all those things. Then you start wondering and say, who said deep learning is simple? Well, deep learning is still simple. It's just you trying to throw in some sort of creating an artificial feature to increase the dimension of your feature space, and hoping that you can map some weights that will be responsive to predict your target. It's really very simple concept, but the implementation, it may just be something that is complex. So always always feel an extra layer of confidence when you are dealing with data science problem that only simple things work. The outcomes result principle still by large means holds for most of the data science application. In my experience, one of those problem area that I worked on when I was in Exxon. It was an interesting, scenario. We spent a lot of time developing very complicated model, tried LSTM architecture, RNN stuff. It's a time series challenge, basically. For like maybe 7 months, we couldn't really get a prediction that moved the needle. But when the project came to be like, I'm the only data scientist left here, I said, okay, let's try simple stuff. Let's just try linear regression in an ensemble form. I, I just create a linear regression for each of the features with time and couple them together, and we're getting some reasonable predictions. So, find solace that simple things work, and it will really take you over and beyond in your career path. Then the next thing is solution comes by much experimentation. You have to really experiment. This is not a career where you have square holes in the square pegs in square hole, or there is like a standard way of how things are expected to come at you. You can see things coming to you many different ways. So experimentation is important. I think the way to also even keep your business folks engaged is for you to be ready to experiment part time. Ready to check out stuff, ready to implement some of some of the ideas you may have. For instance, I am currently working on a project, for instance, and I need to do like some sort of geocoding, and for what that means, I really don't have a location where I have exact record of information, but I have another lookup table that have locations with information. So how do I try to map as much as possible, a location of interest to location in the lookup? You think of measure of distance. How do you measure distance? Do you want to use the Euclidean distance or the Mahalanobis distance, or what do you want to do? Very, 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 very much experimentation will help you. So I experimented a few things. I discovered that simple things work. Euclidean looks complex to me, and I use the Mahalanobis distance, and it works pretty okay. It's able to match things up. So be don't be weary to experiment stuff. That is the way you really get into data science. That's the way you start having muscle memories of a lot of things. Now, this is from a data science lens. If I look at the word data, some of the things that really stand out for me is that you have to understand distributions. It's all about distributions, right? And distribution is just a buzzword. If it looks complicated to you, it's just really saying the count of the distinct member of a set. So if you have given me an observation, and in that observation, I really want to know what are the processes that drive this observation. So I want to see whether it's more of a random or it's more of a with some sort of a systematic evolution of those records. Distribution is really very important. As a data scientist, you would do a lot of checking distribution out and even validating some of the works you have done based on distribution in actual fact. Then, so distribution is a big thing. Algorithms is another thing that comes to mind. What are algorithms? Algorithms are just some sort of some sort of rules or procedures that have mathematical implementation. So it could be an algorithm that it will learn better the relationship between a feature that is discrete and the other, sorry, a target that is discrete, and some set of features which we will still get into and discuss. So algorithms are just figure out instructions that that's already mathematically implemented. You can use a lot of that. In data science, we have a lot of them already prepackaged. And that's when we talk about the ecosystem, you probably will appreciate why Python would be a great tool for you to really probably embrace as a first language in case you're still here to make up your mind. Then tools are very key, right? You need to just know that tools are tools, and tools could mean your programming language, tools could mean your compute resource, tools could mean your story technology. We're going to go into those words because there are three words I know that really put people off and just make them conclude that data science is too complicated for them. So we'll get into that and we'll probably explain it. Then you need to find answers. There are two things that is very important when we talk about answers. There is known unknowns, there are unknown unknowns. So most times in data science, you probably would deal with the latter, which is the unknown unknowns. In data analytics, you deal with the first one, which is the known unknowns. So we know that we don't know this. So how can we find answer to this? Most time data analytics suffice. In data science, is a little bit of a little bit of a deep dive in there. You may really be dealing with challenges of unknown unknowns. So there are some things that we need to know that we don't know, and we don't know that we don't know it. Sounds like very complicated. So these are just some thoughts. I hope that really that really helps. So let's go into this. Yeah, thanks. I think I should be able to cover the content of slides I have. I got them well paced. So most times it's very good for you to understand these three words. One is infrastructure. When we talk about infrastructure in the digital space, usually we are asking two things. We are asking, where is your compute? And when we talk about compute really speaks to whatever is giving you the computational power, which are servers. So it could be, just the same way you have your laptop and you have a RAM power, you have, all those stuff designated to really tell you what is the processing power of your computer. So the same way, when you join an organization, for instance, there will be somewhere, some way where that compute is being being provisioned. So compute and storage is really very important. Storage, like the name just implies, that what tool is really used to store, save data to you, so that when you need to have access to the data that the organization actually do operate on, you know exactly where it is. So now, in the space of infrastructures, there are three types of flavors you will see. There's the cloud, which is totally the case that you don't have the physical data centers, on premises with wherever your company is located physically. Rather, you're using some third-party solution providers like Azure, AWS, GCP. They're the one that is really helping you to provide either only compute, or they're giving you both compute and storage. So, so it's very good for you to really have this map out in your mind that when you join an organization, there will always be a way to provide you the data science, the data scientist a compute. Compute is where your computing power is really, provisioned from, and there'll be a storage. That storage also is where most of their data is, and there are a lot of architecture. So you can see now I'm going to talk about architecture now. There are a lot of architecture that really designs how this infrastructure interacts with you. So when we talk about how you as an individual, that's a user, are able to interact with the infrastructure, it is usually laid out in a plan called, the architecture. Essentially, how you interact with this infrastructure is laid out in a plan, usually called the architecture. So it could be on-premise, meaning that you have everything, physically physically available to your company owns it 100%, and you can really go to a data center that is local and privately owned by your company. And it could be hybrid. Hybrid could be a mix of the two. Some companies that use hybrid is really essentially because they have sensitive data they would not like to share with external third-party providers, and they will keep those ones, on-prem, and they will definitely keep all other insensitive data to be, in cloud. Then we talk about tools. Now, think of tools this way. Depending on the scale of the compute you require and the story that is involved, your technology could distill into different classes, right? It could really be a big data technology. It could be just, single node technology. Now, when you hear the word node, most times in data science, it's really speaking to, all in the digital space, it's really speaking to a computer. So you can hear something that is called a worker node or a master node. It's just, essentially a coordination. So when you have a piece of work, am I implementing that? Am I able to implement that piece of work on a single computer? Or do I need to really have another computer that will partition that piece of work into smaller chunk and, kind of send it out to, different nodes, which are called the worker nodes. And those nodes can really implement that request and, send the result back to the worker node. So depending on the scale of data and the extent of the compute you need, you can have different class of tools. For instance, when we talk about big data, that's where you would see technology like Spark, for instance. You see, Spark SQL. Now, I want you to think of Spark as um, think of it a little bit, just a little bit, that's something that is very, very extensible for big data technology. Just like we have Python that you can use everything with, Spark also is another technology that is very scalable with all the big data ecosystem. But let me really keep the focus here. So you can have data tools and technology. For instance, you have the database that you can really then talk to using a language called SQL. And I will encourage that you guys, learn some more SQL. We're going to go into what I think you should be focusing on depending on where you want to be. So you have a database. So that database could be like a traditional database, which is relational database, whereby every data is really referenced to a key and whatnot. And you can use like a SQL language to ask for a query. Can really implement a query. A query is just a clear instruction of the kind of data you want to get out of a database. Like, I want to get the names of everybody that visited the store from this time to this time. That will be in a query. So you can really write that kind of request in a query and place it on a database and get that response. Then we can talk about transformation tools. Transformation tools are like Spark, and you can see Python there. We still discuss the relationship between Spark and where Spark comes in. For some of you that have some knowledge about Python, you know about a package for data manipulation called pandas. When you talk about that package, essentially, it is only really implementable for single nodes. But single nodes will do poorly if you're dealing with huge huge data sets. So pandas won't scale. It will be very slow. So you need to then move into what is called the Spark data frames. So the Spark data frames have similarity just like the pandas data frame. The only difference is there is that the manipulation operation you'll be running in Spark is actually on multi-nodes. It's not just a single core performing the process of manipulation. You can have a lot of core actually doing the manipulation, and it can make your query really quick, faster. And it's usually a paradigm shift if you move from learning pandas data frame to learn the Spark data frame. You see some things that, oh, I want to do in you can easily do in pandas. When you get into Spark, it becomes really very complicated. Then you have some modeling tools I think scikit-learn is probably, or sklearn is probably the most comprehensive package in Python, where you can see the pre-implemented algorithms that you can try out on different scenarios. Then you have some visualization tools too, right? So visualization really is one of the very important space in the data discipline because you want to empower intelligence at the level of decision making. And most times when you are that interface to make a point clear, you need to really make something visual. So that's why it's also very important for you to, of course, know about tools that will enhance possibility for visualization. And you have some other tools like Kafka, which are like Q, Databricks, which is like enhancing your data, pre-processing at scale and whatnot. Then architecture is really, like I said, is the way you as an individual or how data and compute are managing your workspace. So that's what architecture is. So you see it as like a layout. You see it more or less like a layout. The layout would be like, you're looking at the building plan and whatnot, and you see how this relates to that, access, data sources coming in and whatnot. So architecture just shows you how access, compute, and storage are managed in a workspace. And it can really be designed differently, as case may be. So let's talk about understanding where you may want to begin from. Now, data analyst, I think data analysis is like the lowest hanging fruit, if you ask me. And the reason why is because not a lot of organizations are matured in terms of their enablement to implement data science at scale, because there are some enablers that are really critical before your data science, before data science can deliver at a promised level. So of course, but data analysis is something that is probably more accessible to organizations, even if they have not invested so much. For you to have a data science team that is really efficient, sometimes it may require some investment into your data ops. So, and we'll talk about that in a couple of seconds. Now, what does data analysis? What does it really entails? Well, the scope is a little bit smaller than the scope of a data science, than the scope of data science. The scope here really is to help business answer questions that they know, and really to provide that answer in visual models. So you usually, design visual models, and two things that you use strongly as data analyst is really, in terms of tool, you're going to use the SQL. Your SQL skills need to be, on top notch, and it doesn't mean it's complicated in any way. You just need to know how to do a couple of joins, how to do a couple of, a couple of window functions, a couple of, answering some really complex business questions by writing queries. So your SQL skills need to be on top of it for a data analyst, and you need to learn how to really translate those insights into visualizations. The two tools that you would really see a lot is Power BI and Tableau. So I would say confidently that you can really become a very industry-ready, data analyst if you're very great at the use of SQL, query language, and you are able to tie SQL, of course, to any of all these front-end visualization dashboards, like tools like Power BI and Tableau. So these tools, so if you're thinking of data analysis, definitely focusing on these tools will help. Then data engineering, I can tell you, is kind of very interesting. And I think most organizations are still trying to figure out their fit in their data engineering practice. So what does data engineering entails is about what are the end-to-end process of how you make data available in your organization. In what form? Is it very refined, or you still have your data very crude? There's a word that is coming up very, very strongly now in the digital space. It's called data hubs, which is really around you ensuring that data and operations are working, together. So what that means is that you are able to give everybody in the organization the right access to the data they need almost automatically. Like, for instance, if I'm a data scientist and I need data at different specification, let's say I'm talking about a time series data. If I need that data, for instance, in hourly frequency, I definitely do have access to it. If I need that data in some sort of form or shape, I definitely have the architecture, or I have a well laid out process that is already implemented that data access for me. Now, the two keywords that you really be fiddling with in data engineering is that the ETL architecture or the ELT architecture. Now, in terms of design, traditionally it started with ETL, but now things have moved on to ELT. The reason is because the ETL is kind of expensive and exhaustive, because what it does is that it pulls data from their original database and process all the data and preserve the data anywhere else. So it has to process all the data, whether it's needed or it's not needed. It does all the processing all at once. So the efficiency is really questionable. Why the ELT, which is a modernization, only process the data that is needed per time. So, but the challenge of the ELT is that it makes your data also to be very varied. So you're going to have processed data on processed data sitting somewhere in your server and your data space. So it comes with its own concerns too. But one way to really work on that is governance. So if you're interested in data engineering, one of the things that will be very important for you to learn also, of course, will be SQL. You still need to do a lot of SQL. You need to learn a lot about the technologies like Hadoop and Spark. Spark really becoming highly favored now because it's very efficient, it's faster, And it's really inexpensive because you don't need to have a different computation nodes to implement the manipulations that is required. Unlike unlike Hadoop, that is really very extensive in terms of its requirement for processing, compute, and storage. So for data engineering space, you need to learn something like Spark. You need to also be very good at at your SQL, because most of the time the traditional databases that is being used is still this relational database. So that's just some sort of high level. Now data science, very high end on the chain. Most organization thinks they are doing data science, like I mentioned, but they're not quite there yet, because data science requires some enablements. If you want to do it at scale, for instance, you need an end-to-end technology. You need to have data readily available, because most times if they hire you as a data scientist, you may end up doing the work of a data analyst, but they give you job the job description or the title of a data scientist. So you may end up doing data engineering and data science, which is really not uncommon in many organizations. So let's look at the key areas in data science. Business understanding is very key. And if you go for interviews, these are some of the things they really want to see, whether you understand how the workspace in data science works out, right? How things are done, as a data scientist. Your business understanding is for you to understand the business, to understand the business rules, to understand, what the business intentions are, to understand what needs to be optimized, to understand the pain point most times. So it's more or less like, you're trying to acquire some level of domain knowledge so that you can have confidence to face any challenge that business is facing. Then you do data understanding, where you try to understand the variety of data that is available to the organization. You'll be able to assess whether that data will be sufficient for the intended business problem that they want to solve. And you then of course advance into the modeling space. So I'm going to show the workflow for data science, which I think you can think about. You can use it to start modeling your thought around how a data scientist work in actual fact, in a practical sense. Now you can see tools there. You can see R and Python. Those are the common ones in terms of ecosystem. And you can see that those two tools are further divided into two. One is sklearn. For instance, we look at Python, there's sklearn icon there, there's TensorFlow. The reason is because when we talk about machine learning, there is the traditional machine learning, which is feature-based, which means that you know the features that you're trying to learn something from. There could be deep learning based, whereby you don't know the features, you're just trying to figure out the mapping. So you really don't know what feature and how one feature relates to the other. You're just trying to use data to help you understand what will be the relationship between features. So that's the kind of structure you see in most packages, in most language. So if you see R also R also have the traditional machine learning feature-based package implementation, and it does have a deep learning base. And you can see Plotly and Streamlit. These two technologies are changing games, how a data scientist could really now do things end to end. I can develop a model and I can build a product. So with Plotly, and we have a workshop coming up where we're going to be using Plotly to deliver an actual product from the data phase right into the product phase. Streamlit is also with just like an option to Plotly. So the Streamlit, these are all like high level languages that have been written so that you can develop very great front end solutions. Even as a data scientist, you don't need to know React, you don't need to know Vue, you don't need to know JavaScript that deep. You can still stay in Python, which is your primary ecosystem, and you can develop product end to end. You can do your data analysis, do your data understanding and whatnot, and you go right into it. This is just a blow up of business intelligence data analysis. What are the tools you need? Be very confident about your SQL. Try to learn how to use a SQL query language, and know how to translate your queries into dashboards and visualizations. And I think in my feeling, this is probably one of the most beginner friendly section of the career discipline. Then data engineering is kind of a little bit more more extensive. You have the Spark there. I think Spark is the major one. If you're really great at understanding Spark and its parallel computation paradigm, you'll be able to really do some complex data manipulations and whatnot. And there are some other technologies, like you can see, that Spark really works well with. So that's why learning Spark gives you the benefit for you to have like a way to still interact with all the other technologies in that ecosystem. Now, data science in actual fact is not artificial intelligence exclusively, because when most people think of data science, they think of it as artificial intelligence. Although it's a bit of it, but a data scientist has lots more, to take care of. A data scientist would do a little bit of AI, do a little bit of machine learning, do a little bit of deep learning. And just to let you know, the difference between AI, machine learning, and deep learning, or the difference between AI and machine learning is just saying that AI is like everything, but machine learning is a specific type of AI that extracts intelligence from data. Artificial intelligence could extract intelligence from anything, could be rule-based, it could be whatever, but the specific aspect of machine learning that extracts intelligence from data is machine learning. Of AI that extract intelligence from data is machine learning. Now, if you now look into machine learning itself has a niche. So in machine learning, you could do like feature-based learning most times, maybe whereby you're trying to do like an hedonic modeling, whereby you have set of features, and those set of features you're trying to understand their express mapping to a target. So you know the features you're dealing with, you exactly know that you're trying to, or you engineer some of those features, but they are all feature based. So most times, machine learning would involve both feature based and the other part, which is deep learning. Deep learning is not feature based. Deep learning is really you trying to learn from a massive data and trying to figure out, which high level dimensional space will be the feature that would be most important to predict a target. You may be starting with 3 features, but each of the neurons and layers you are creating are some secondary features that you have created. So you're trying to see if you can expand if a finite feature set into a higher space and come up with some sort of more features that would help you enhance the understanding of a problem. But in actual fact, deep learning is the one that's giving us really great, performance and possibility at human level intelligence. Machine learning by itself, traditional machine learning cannot really achieve that level of intelligence. So at the level of deep learning, we see cognitive intelligence, like, computer vision, natural language processing. All those only came back by deep learning, where we have too complex feature space that we cannot really explicitly define or kind of hand make their feature engineering. So artificial intelligence is intelligence from anywhere. Intelligence from data specifically is machine learning. Then machine learning could involve you knowing the features or engineering those features, or you just leaving everything to extract those features from data, which is what deep learning does. Now, data science, is kind of special because you're going to be doing a lot more than just, wanting to do prediction alone. You're probably going to be doing some analysis. You're also going to be, concerned about, monitoring the life cycle of a product. You're also going to be concerned about, continuous improvements of the product that you have developed. You have relationship with business to maintain. So there's a lot more that a data scientist would do than just the predictive parts, which is really in the AI space. So these other parts of the circle that you see lying outside there, it really entails you as a data scientist being able to do, on top of your predictive capabilities, being able to do like end-to-end life cycle product management, because when you develop your model will not just be good straight out of the box. You need to ensure that you keep monitoring the metrics of that model and it keeps, keeping up. So you can just see the blown up version of R and Python there. The structure is still there. You can see traditional and deep learning based. Then we have, there are 3 things I also want to point out. My time is really fast spent, but I'm concluding. Is that we could have supervised learning, meaning that you definitely want to solve a problem that you have, a subset of observations that has the exact prediction you want to make, and you have both the answers, you have the labels as it called, and you have the features. So if you have that kind of problem where you have a subset of observation that is complete, it's a supervised learning. And there is a semi-supervised, paradigm that is coming up now, whereby, you are able to start with a data set that you take into into another realm of a new data set. That is, you're trying to transform your data set to another data set, And that new data set that you have really transformed your data into is what you want to use to predict. For instance, we talk about the autoencoders. Those are really examples of what you could call like a semi-supervised architecture, whereby you just transform your data set into something else. Then that data set now, you now use it to learn, target, or whatnot. Unsupervised means, of course, you don't really have answer. You just want to use cluster to know what are the rules that determines where your observation falls. So you don't have any labels. You're just trying to really look into your data and figure out what is going to be responsible for the rules of how they fall into different domains, essentially. So we have continuous and discrete variables. I'll talk about this in the next slide. So these are some of the tools that you would see. SAS, people use SAS in the organization where I work to. So I saw a SAS code. I was like, wow, people use this as well. So it's good for you to be aware of it. But I tell you, out of these three, if you're a beginner, it's probably easier for you to start by Python. And this is just a comparison of R and Python, what really inspired it and whatnot. What you discover there is that programmers will probably incline more to Python. That is, developers are more Python inclined, while researchers are more R inclined. So now the generic data science workflow is very important to understand this. When we talk about the data science workflow, there's an exploratory data analysis to it. And I just highlighted what I do at work here. This is essentially what I do. So when I start a project, what do? I want to grab the data, identify continuous variables and discrete variables. This is going to be a good workflow for you to kind of understand. There's no time for me to really explain this, but I believe if you follow this workflow on any project, yep.
Sorry, just to jump in for a second, we will probably upload this slide deck to Slack, so people can also read through these decks. So maybe you don't have to be too rushed in explaining this. And yeah, just a reminder. Thank you.
Yeah, absolutely. Thank you for saying that. Yeah, I mean, there are some real very important details I really want to touch here, like really talking about your test train strategy design, which really is what would define the confidence on your model, right? It's very good for you to think of it in a way that, how can I really say that my model is really performance, and what I say it's going to deliver is probably what's going to deliver. And another one that I think is just an highlight that I need to point out that a lot of people don't talk about is data drift challenge. When you have developed a model and the model has been going on, how do you measure that your model is still going to be definitely relevant to the new data that is coming in? So you need to do like data drift analysis and whatnot. So that's data science workspace. And well, next steps to grow in your career. Just to say, I hope I've not confused you. The three things I've really highlighted this evening is that data analysis could be something if you think it works more for you. If you like answering business questions, if you like querying database, operational database, coming up with insight and really translating that insight into a visualization in form of a dashboard, you can really appreciate more space in data analysis. If you like really working more on getting an organization, be data responsible, having a more structured organization of data, having people who have access to the data they want, and ensuring that you can be you can be guaranteed of great data governance. Data engineering is probably a good place. You just need to learn both the tools, the technology, and the architectures, because that's the way you learn things in data science: the tools, the technology, the architecture, the tool, the technology, the architectures. If you follow those patterns, you probably find that you are seeing structures in what you learn. Like tools, for instance, in that space could be something like Spark in data engineering. Architecture could be ETL, ELT, which is really how things flow. And your technologies ranges from a lot of range, Kafka, all those things, queue and push, pull, all those things are different types of technologies that are available. Now, learn one of the key data science ecosystem. Python is a good one. On a high level, we want to learn Python, NumPy, Pandas, Matplotlib, and Seaborn, and and scikit-learn, you probably will be able to deliver a basic data science with the knowledge of all these packages. Then I would advise that you explore this data set. There are two types of data set in data science. You could have like an academic data set and a real life data set. You know, I was actually part of those interviewing for an intern role, for the data science intern role for a company. And you know, one of the candidates was talking so much about data, so I was like, what's the difference between an academic and a real data set? So it's good for you to understand the academic data set are intentionally manufactured to actually, express a particular modeling challenge. So if I want to, for instance, check for a classification challenge, I can manufacture a data that will be difficult to really create a boundary on. So academic data sets are really manufactured as a benchmark. So that's why you see when you read algorithms, they will tell you it's benchmark on so-so data set and breast cancer data sets on so-so data set. So academic data sets are manufactured, to intentionally, make a problem, generate a problem that will be difficult to solve. So, and it's a true test of the strength of algorithms when it comes to state of the art. While your real data sets are just like very real. And if you follow this link, you see all the data real data, repository that you can have access to. Start building your knowledge of solution approaches, know how to handle classification challenge, regression, time series clustering, and listen to some, talks. Some talks can help you. Like PyData has a very great content. You can get to check their YouTube channel. Fast AI also have a great, repo of knowledge that you can check out. And, you can look forward also to our workshops. Now, if you're the type that really like, reading, these are books that I have read myself. Like, it's not books that, sometimes you just tell people to read a book. Like, I read Francis Collett. He did a very good job. And this is the author of Keras. This book is really one of the books that I think would help you if you really have genuine interest to understand data science and machine learning. If you read this book, you understand, a lot of way to think about data, array, tensors, all those things is really well clarified. And if you're the type that really wants to use Python at any slight opportunity, I'll recommend you to read this book or try to practically implement or understand what this book automates the boring stuff is. Then the statistic guardian that I have used that has helped me in conversational statistics and also in practitioner statistics is statistics in plain English. If you're the type that like reading, like I said, I don't think it's a prerequisite for you to be a good data scientist, but like type that like reading, these are really good stuff that you can do. And that's it. It's very difficult to, I think I'm like 3 minutes out of my time, but I hope you guys maybe find one or two values out of this, and probably we will have your time again to then go through a section where it's going to be more hands-on and less of talking, and we'll see how this will improve your chances to make it work for yourself in the data discipline. So that's all I got. Thank you, guys.
All right. Thank you so much, Michael. I know you're trying to cover a lot of material here, and it's really, really well thought out. And I appreciate you putting in the time of putting this together. And thanks for everybody else. I know we're a little bit over time, but I just wanted to take time to recognize everyone who joined the meeting and who's taking the initiative to learn. And so we have set up a Slack channel to post all of the workshop materials. So don't worry if you didn't follow some of the material that Michael went through. We're going to post the video and the slides to the Slack channel, but remember to register for our next workshop, which is going to be in 2 weeks on September 24th. Only the registered people will get the workshop material. So please remember to use our website to register for the next workshop. We're planning 5 of these workshops as a series. So if you're interested and want to continue to learn and participate in the projects, please join the Slack channel and use the website to register for the next workshops. And as we said, as Michael also alluded to in his presentation, we're planning for a project for you guys already, and we're going to be posting the data set for the project, and you guys can start exploring with some of the tools that Michael mentioned in his presentation yourself. And on October 8th, I believe, is the workshop that we're actually going to go through the project with you and show you our solutions. It's going to be an end-to-end machine learning development solution. And thanks again for joining, and please let us know if you have any questions. We're going to send out follow-up emails for how you think this session went, and please do us a favor, fill out the survey so we can bring you better experience, even better experience than next time. Okay. Thanks a lot. And thank you again, Michael.
Thank you, guys.
Yep,
thank you very
guys.
much, Monica. Thank you.
Appreciate it.
Yeah, thank you, guys. Thank you, guys. Have a good one, guys. Yeah.